In this video, we're going to plot a conductometric titration curve and get the endpoint for the titration from the curve. So here's some data that I have collected for a titration of 100 milliliters of an unknown HCl solution with 0.1 molar NaOH. And I start off with a pretty high conductivity reading before I add any sodium hydroxide. And not surprising because hydrochloric acid contains hydrogen ions which conduct electricity very well. So it starts out very highly conductive because of the hydrogen ions, but as I add more and more sodium hydroxide, it reacts with more and more of the hydrogen ions and takes them away, locks them up in a water molecule so that they can't conduct anymore. And I see the conductivity dropping as I'm adding sodium hydroxide, until I get down to this point that I've marked in green. And then the conductivity starts to rise again. What's happening here is that all of the hydrogen ions from the original HCl solution have been neutralized around this point, and now I'm adding excess hydroxide ions. Hydroxide ions are very good at conducting electricity as well. They, as the hydroxide ions build up, I'm seeing a higher and higher and higher conductivity. So when I plot this thing, I'm going to see a drop and then a turnaround right here. And this turnaround here is going to be roughly where the endpoint of the titration is going to be. This is when I have added enough sodium hydroxide solution to completely neutralize my unknown HCl solution. But I don't know exactly what the volume is going to be. It could be between 10 and 11.03. It could be between 11.03 and 11.99. I don't know. So let's take a look at a graph and see how we can nail that down a little bit. I'm going to click off my data, and I'm going to come up here to Insert, Charts, Scatter. So now I have an empty scatter plot here, and let's go ahead and put some data in there. I am on the chart design ribbon, and I see the select data item. When I click on it, I get this little form for adding curves. How about if I add all the data and see what it looks like? I'm going to call this the complete or the full titration curve because it includes all the data, and the X values I can select here, and I click on this to select the Y values, and those are the conductivities. Okay, so my titration curve looks like this. The point of interest is going to be in here somewhere, either between these 2 points or between these 2 points. I don't quite know yet. Looks like between these two. And I'm going to say OK. And I think what I'm going to do to locate the endpoint exactly is I'm going to fit a line to a few points on this side and a line to a few points on this side. Extend the lines forward and see where they intersect. And that will tell me where exactly the endpoint is going to be. So let's add some additional curves on, one that includes maybe these points right here. And I'm going to say add. And this is on the too much base side. And the X values are going to be, let's see, we're going on this side of where that minimum is. I'm going to pick maybe 4 points. And the Y values are going to be maybe 4 on this side of this point right here. And I'm going to say OK. And now notice I'm going to make a line with that and extend it down here later. Now let's add some points on this side that we can do that with. I'm going to add on the too much acid side. And the X values are going to be maybe 4 on this side. And the Y values are going to be maybe 4 on that side. I have to have the same number of X and Y or it won't work. And I'm going to say OK. So I have a curve here and a curve here that I can fit a line to, lit up. I'm going to say OK. If I forget to hit that button, it's going to just erase everything. And now I'm going to do a quick layout on this curve. Still in the chart design ribbon, I'm going to come up to quick layout. I'm going to pick the first layout. It has everything that we need. We don't have to look at the others. And I can put in my chart title. It's a bit of a long, windy title with a lot of things included in there, but I don't mind it because if I have that information and the graph, it's going to tell me everything I need to do to calculate the molarity of the HCl. Let's finish cleaning the graph up. I'm going to put my axis titles in. And it's important to have your units always in your axis titles. Okay, and now let's draw the lines. Let's draw the line on this side. When I click on the gray points here, they lit up and it's showing me where it's taken the data from. So that's good. I do not want to fit a line to the whole thing because this isn't a line all the way out. Both of these things curve on either side. So I got to select just a few points on either side of where I think the endpoint is going to be. And let's fit a line to this. Once they're selected, I'm going to right click and I'm going to say add trend line. And it shows me the trend line. I would like the trend line to extend down this way somewhat. So let's forecast it forward maybe about 2 units. And let's go ahead and show the equation and the r-squared value on the chart. The r-squared value tells us how good the line is. It's pretty good. One would be all the points are exactly on a line. And it extended it down that way. Let's do the same thing over here for these points. I'm going to right click on them and I'm going to say add trend line. And I want this trend line to extend down that way, so I'm going to forecast backwards maybe 2 units. And I'm going to put the equation and the r-squared value here. And let me drag it over here so it's pretty clear that I'm using it on this curve right here. That also looks like a pretty good line. I can see where the intersection is. It's just a little bit to the left of where the 11.03 is right there. So, okay, this is everything that I need. I should attach this graph to my report form as a PDF. I can get it into a PDF by making sure the graph is selected here, going to File, Print, and I'm going to make sure my printer is Microsoft Print to PDF, and I'm going to hit the Print button, and it's going to save it as a file somewhere. It's wanting to save it to my Downloads directory, and I'm going to say maybe titration curve and put my name in there. And I'm going to say save. And as long as I remember where the file was, I can upload it to Canvas later. Now, how do I get where that intersection point is? Well, I have the trend line for this, and I have the trend line for this, and they both intersect right there, so their y values are the same there. So let's call this one y equals m2x or m1x plus b1, and let's call this one y equals m2x plus b2. Then I could set those two equal to each other. m1x plus b1 is equal to m2x plus b2 at that point. Now what I can do is solve this for x. Solving for x means I have to get x all by itself on one side. So how about if I do this in a little bit of detail? I'm going to do the algebra. I'm going to get this B1 over to the other side by subtracting B1 from both sides. And now I want to get the M2X over to this side, so I'm going to subtract it from both sides. Now I'm going to factor out the M1 minus M2. And now I'm going to divide both sides by what I have in parentheses there. And now I have an equation for the endpoint. Let's go ahead and put in the values from our trend lines here. Okay, M1 is minus 0.2563. B1 is 3.6746. M2 is 0.2485. And B2 is minus 1.7723. The minus sign comes from the fact this is y equals mx plus b. So if there's a negative number there, you've got to include it in your b value. Okay, so let's calculate x. X equals, parentheses, the parentheses are important, b2 minus b1, close the parentheses, divided by parentheses open, m1 minus m2. Okay, so it's 10.79 is where it's telling me the intersection is. That's my endpoint. That's how many milliliters of NaOH it took to completely neutralize the HCl. All right, I could figure out how many moles of NaOH I have from that. If I multiply the volume in liters, and that's the milliliters, divided by 1,000, times the molarity, which was 0.1000, we said, that gives me moles of NaOH. And that's equal to moles of HCl in my 100 milliliters of solution. And if I want the molarity of the HCl, all I got to do is divide moles of HCl by liters of HCl. We had 100 milliliters, which is 0.1 liters. So I'm going to say the molarity is equal to moles of HCl divided by 100 milliliters, which is 0.1 liters. And there's the molarity that I calculate for my unknown HCl.